Alright guys, so this will be kind of a review for how to sketch a graph using the transformations that you already know. So looking at this form, we know that this form is really general. The A, the H, and the K tell us information. So remember that A always tells you if it's reflected. A will also tell you if it's stretched or compressed. H, the number on the inside, that always tells you about horizontal movement. And that means whether or not it's moving left or right. So the horizontal movement is always opposite of what you see. So if you see a -2, your graph is really moving to the right too. Now K is going to tell us vertical movement. And that vertical movement is up or down. It's just whatever you see goes. So if you see a +5, your whole graph's moving up 5. So let's talk about these other parent functions that now we're going to start seeing more of. So we're going to start seeing higher degreed parent functions. We're very comfortable with linear, which is degree 1. We have x squared, which is a quadratic. Now we can have higher degrees. That's what this section's all about. So looking at this graph I already have here for you guys, you can see that I have 3 functions graphed. The first one, the one that's in black, is your y equals x squared. That's a parabola. That's what you're used to. That's a quadratic function. You can see it goes right through the origin, which is 0, 0, and goes back up. So that is just x squared. Now the red function, the one that's a little bit, maybe a little bit wider, you could say a little bit flatter at the bottom, that's your x to the 4th function. That's called quartic. You don't really reference it as quartic too much, but that's its official name. You can see that also goes through the origin, is just a little bit wider and a little bit flatter at the bottom. And then the last one, the blue one, is x to the 6th. So same properties where, you're going through the origin, both ends are going in the same direction, and it's a little bit wider, a little bit flatter in the bottom. So you do see some similarities between all of these functions. So some of the similarities that are really plain and simple is that they go through the origin. Oops, let's erase that. And they go through the origin, and then the other major quality that is really similar is that the ends are going in the same direction. So the ends go in the same direction. Okay, so that means that both ends of think of a parabola, both ends of your parabola are always going up or going down. You're never going to have them like opposite or switched. Okay, what else do these functions have in common? If you were to look at just the equations, you have x squared, x to the 4th, x to the 6th. Think about what these have in common, and that's actually going to come into play in our leading coefficient test. Let's look at our other option, right? So our other really common function that we've seen was our x cubed. So x cubed is the one in black. You can see it looks like our good old-fashioned x cubed. It goes to the origin. Our ends are going in opposite directions. Okay? X to the 5th is similar. Goes to the origin. It's the red one. The ends are going in opposite directions. But you can see it's it's taking a little bit longer to go up. It's a little bit flatter, longer. It's kind of like wider, if you want to call it that. Then we have our blue one, which is x to the 7th, so an even higher degree, but it does have similar qualities. Goes through the origin. The ends are going in opposite directions, but again, it's a little bit wider, taking a little bit longer until it starts going up. And you can see that it really mimics the same qualities, but it's just slightly different. So let's use these parent functions now for when we're rewriting or sketching transformations. So we're just going to do about one example through here because you've done this before. If you need more help, just shoot me an email. So on this example, we have a couple things going on. So we're going to figure out the transformations first. Then we're going to try to put it on our graph. So for me personally, what I like to do is I say, okay, my parent function is x to the fourth. So wherever you want to write it. So parent function, mine's going to be f of x equals x to the fourth. So I'm just going to draw my parent function. I'm going to draw it in black so that it's just kind of like there for me to see. So this is x to the fourth. I'm going to make these values equal 1 and negative 1. A little bit flatter, then it's going to go up. Going through the origin, a little bit flatter, then it goes up. Let's make that look a little bit nicer. Alright, so that's like kind of what the x to the fourth graph looks like, a quartic graph. Now we're going to try to sketch the transformation. So the things that I can see from my equation is that the negative in front tells me that it's now going to be flipped over. And the plus 2 on the inside of the equation tells me that now it's moving to the right. So this negative 1 tells me that it's reflected. This plus 2, sorry, I think I said to the right, but it's actually moving to the left. We go opposite of what we see, so to the left 2. So if you think about those 3 specific points that we had, let's make our graph look a little bit better. We had a point at 0, 0. I'm going to be moving it to the left 2. So now it's going to be at negative 2, 0. Now, my graph got flipped over and moved to the left. So if I move my other points over, right? So if I'm looking at this point right here, I know I'm going to move it 2 to the left. So it's going to kind of end up here, but then it's going to get flipped over. So instead of being at 1, it's going to be at negative 1. So that's part of our final graph. I'm going to make it green. And then I have the same thing with this little point over here. If I move it to the left 2, it kind of ends up like right around here. Then it gets flipped over. And when it's part of my answer, I'm going to make it green. So my graph is like wider and flatter than our regular parabola. And that's it. Okay, so a sketch does not have to be perfect. You just have to be able to identify the transformations and show them on the graph. So for instance, this one was reflected and also shifted left 2. Okay? If you have questions, ask me, look them up. Email me, email a friend, do anything you need to do so that you can understand this, because this is a review topic.